What's up, guys? I started my last recording and then I accidentally removed my colors. I didn't know where they went, so I have to restart this. Anyways, this is help on your assignment for arithmetic sequences. I am going to be going all over through question A. However, I do want you to try the assignment on your own first. If you haven't given it an honest shot yet, please go back. But if you're really stuck, stick around. I'm going to show you how to solve A, which will help you solve B, and then help you solve C. Another thing is, if you have not seen the other video that's simply titled Arithmetic Sequences, please watch that one first, or you're going to have no idea what I'm talking about. Okay? So let's get started. Question A1. One other thing. I'm not having you do all the questions. This has like a fourth question to it. Make sure you look at Google Classroom because I'm not having you do all of the questions, just the ones that I'm asking you to do. Anyways, copy and complete the table below. Follow the linear function pattern suggested by the 5 values of A of n. Again, we're looking at this as our term, and these are our actual numbers, our A of n, what numbers are coming out of it. When we're looking at this, we're looking at what is our constant change. We are adding 200. It's arithmetic. We know that it's arithmetic, so that does mean it's adding. So we're looking at adding a number every time. Adding 200, and so on. And we can use that to finish this up. 900 plus 200 is 1100. 1100 plus 200 is 1300. And we're going to kind of continue riding the odd train into oblivion. Boom! There we go. What is the relationship between each term in the sequence and the next? This goes back to what I was talking about beforehand, where you have n plus 1, you have n minus 1. This is your current term, this is your next term, and this is your previous term. And again, this kind of helps you guide back and forth within this sequence. And specifically, what we're looking for, what is the relationship between each term, which is our current term, so we're using current terms, in the sequence, and the next. So we're looking at these two, current and next. Express the relationship as an equation relating each term, A of n, and the next term, n plus 1. Notice we have n and n plus 1. N and n plus 1. So in other words, we need to write an equation. So this is going to be A of n is equal to, and I know I have to have, it's a relationship between these two. So I have this one, and I have my next, which is A of n plus 1. Close. Now I got to think about, how are these two related? I know they're not equal, but how are they related? So I have, let's say I pick 5. This one. 5 and 900. So I'm going to say my term is going to be 5, and my n, is going to be 5. Cool. I can simplify this. This is 5 plus 1. It is my next term, so it's actually going to be 1 after 5, which is 6. I can plug these ones in. A of 5 is 900, is equal to my 6th term, which is 1100. But that's not right. I have to change this side somehow, right? So what I need to do is subtract 200. 900 is not equal to 1100, but 900 is equal to 1100 minus 200, which means in my original equation, I need to subtract 200. So if I go, actually, let me just do this. If I go all the way back, boop, 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 my equation is going to be A to the power, or A of n, is equal to my next term minus 200. And that would be what it's asking for here. Let's say instead of asking for the next term, let's say it was asking for my previous term. So that would be A of n is equal to my previous term, which is going to be A of n minus 1, previous, and I got to think of how it's going to be related. It's still changing by 200, but rather than subtracting it this time, we're now adding it. So for example, wherever I am on my sequence, if I'm at 2, I'm going to, if I want to know what 2's value is, I go to my previous value and I add 200. So 100 plus 200 gives me 300. If I was at this point, if I was at this point, 3, I need my previous term and I'm going to add 200. Previous term, add 200 to give me 500. So it's kind of all about, it's really very reliant on term placement. Where are these terms in here? Cool? But it didn't ask for the previous term, it asked for the next term. So that is the equation in terms of the next term. The next question says, what algebraic expression shows how to calculate a of n, so we're still looking for a of n, for any value of n without finding every term in the sequence. So that's kind of where a sequence starts to break down. This part here requires you to know what the previous term is. In other words, I can't find what this is without knowing what its next term is. So it wants a way for us to be able to put this together. This is just, at this point, a regular sequence. Y is equal to mx plus b. Once again, mx plus b, our m value is going to be our change. And again, I want to highlight the fact this does not mean we're making a linear function. We are basically creating a sequence, but we can use what we know about linear functions to put something together because these guys are so close. M is going to be our change, and B is going to be where we start, or at 0. Cool? Where we officially start at 0. So what we're looking at here is our change, once again, when we come back up here, our change between these is adding 200. So our slope is going to be 200. That was our change. The B value is where we start, where x, or in this case, n, is equal to 0. It doesn't tell us where it's equal to 0, but I can guess. I know the pattern is adding 200 every time, so if I go backwards, I got to subtract 200. Which means my starting point is going to be at negative 100. So instead of b, minus 200. So now I have my change. Oh, not 200, my bad. I have my change, and I have where I'm starting, negative 100. And if you're ever unsure if your equation is going to work, you can always just take one of the terms and plug them in. So let's grab, let's say 3 and 500. So 3 is my n value, and a of n is equal to 500. So this will be 500 is equal to 200 times my slope value, which is actually n. $500 is equal to 200 times 3 minus 100. 500 is equal to, this would be 600 minus 100, and 500 is equal to 500. That checks out, so the equation works. So this would be my final equation right here. Answer to question 1 is filling in the table. Answer to question 2, write it in terms of either the next or the previous, whichever one it's asking for. And answer to question 3, you're writing that kind of linear-looking equation for this sequence by using finding the change. How much is it changing by, which you found in the beginning. And then, where is it actually starting? Remember where it's equal to 0. Cool? If you guys have any more questions, please feel free to leave a comment below. Just telling me you're confused doesn't really help me at all. So tell me which question you're having problems on. Say, hey, Mr. Ernst, I'm stuck on A3. I know I watched your video. I still don't understand it. And I can try and work on it with you from the comment section. Or if you want to come into the Zoom meetings Monday, Wednesday, and Friday at 10 a.m., then I can help you there. Okay? Cool. Talk to you later. Bye.